This video is produced by Pooja Gade and Eduardo Coleman. The experiment we are going to present is a double displacement reaction between sodium hydroxide and nickel chloride. A double displacement reaction is a type of reaction where part of one reactant is replaced by part of another reactant. Double displacement reactions take the form AB plus CD equals AD plus CB. To perform the experiment, the materials needed are as follows: two 50 milliliter beakers, 15 milliliters of 1 molar sodium hydroxide, 6 milliliters of nickel 2 chloride solution. The first thing we do is take out two beakers out of the container's shelf and we place them on the workbench. To do that, we click onto the container section that is located under the shelf. A series of containers appear. We hold on to one of the beakers and drag it onto the workbench. We complete the same manipulation with the other beaker. Then we name each beaker by double-clicking on them and changing the label container. The first beaker is named Beaker 1. The second beaker is named Beaker 2. Afterwards, we need to fill in each beaker with the appropriate volume of reactant, so we click on to the Materials section visible under the shelf. A series of materials appear and we select the aqueous solution sodium hydroxide. We hold onto it and drag the sodium hydroxide onto the first beaker. A window opens which serves to decide on how much volume we need to fill in the beaker with. For sodium hydroxide, we choose 15 milliliters. We then click again onto the Materials section visible under the shelf, and this time we select the aqueous solution nickel 2 chloride. We hold on clicking onto it and drag the nickel 2 chloride solution onto the second beaker. The same window opens and we decide to fill in the second beaker with 6 milliliters of nickel 2 chloride solution. We can see that the color of the nickel 2 chloride is green and the color of the sodium hydroxide is gray.
The following step consists into pouring the content of one of the beakers into the other. In order to do this, we hold on clicking onto the second beaker, filled in with nickel 2 chloride, and drag it towards the first beaker, which is filled in with sodium hydroxide. Consequently, a window opens. It makes you choose the volume of solution you want to pour in the other beaker. We choose Pour All. As the content of the second beaker empties into the first beaker, a reaction takes place. We can see that the color of the solution is gray and that a small green precipitate has formed at the bottom of the beaker. In order to see the products of the reaction clearly, we zoom in the filled beaker by clicking onto the plus sign located at the bottom right end of the screen. This observation translates the fact that aqueous solution of nickel 2 chloride has reacted with an aqueous solution of sodium hydroxide to produce a solid nickel hydroxide precipitate. The atoms remaining suggest that the other product of this reaction is an aqueous solution of sodium chloride. This is consistent with the WABQC.org data, which is a chemistry site that balances chemical equations. The data says that this reaction should produce both a precipitate of nickel hydroxide and an aqueous solution of sodium chloride. This reaction of double displacement can be summarized by the following equation. So, to be more specific, we see that 2 moles of aqueous sodium hydroxide react with 1 mole of aqueous nickel 2 chloride to produce 1 mole of solid nickel hydroxide and 2 moles of aqueous sodium chloride. Having completed the experiment, we have to clear out the workspace. In order to do so, we drag each of the material we use to complete the reaction in the organic waste, located at the middle bottom of the screen, as follows. Thank you for watching.